Okay, guys. So, yeah, sorry for the delay. There had been some network issues at my side. Uh, Frequent power cuts, so the Wi-Fi gets pretty unstable. So, last time we were almost done with the algebra part. We have just two more things. We'll have a few advanced sessions as well. So they are in the pipeline as well. So if you guys have it, we'll have it after DILR. So as to just give you a short break from Quant. The last two topics that are remaining is permutation, combination, and probability. So today we'll try to cover a major chunk of PNC. If we get it done, that's great, and we'll move to probability if time permits. If not, we'll see probability some other time. So today, as usual, let's start with PNC. So the two important parts that our session would be based is permutation and next combination, the two words after which the chapter is named. They have some similarities, they have some differences. We won't go into how the derivation part of the formula is, but we'll try to understand that what are the significances each one carries. So anybody has any background idea what is a permutation?
Number of ways in which it can be arranged.
Okay, and then what is a combination?
Number of ways where it
Us,
can be picked.
yeah, selected.
If this could have been the VARC class, I would still given you 10 out of 10, but I did not understand the difference between arranged and picked. So can you please
Uh,
care to explain?
Actually, we don't give much importance to order in combination, whereas we
Okay,
give importance to order in permutation.
perfect. That's great. So can you give me a short example, a simple one?
Uh, like forming a three-letter word from five letters.
Okay,
So here we can, I mean, where there
ah,
is no order is not important.
okay.
So we
Hmm.
can form in different ways. But for suppose A, B, C are there, so we need
Mhm.
to put A, B together so that number of ways it can be written. So that would be combination.
Okay. Yes, you are quite correct. So stating from the same example, like I said, let's have a simple, and you might have quite had it in your 10th or 12th standard as well. Let me give you a simple one like this. If you were given and you were asked if I have to pick letters from this and form 3 to 4 letter words, how many words can be formed? Then what you will use is a permutation. But if I say that 4 letter words has to be used, but the second one has to be a consonant, it cannot be a vowel, and the final one has to be a vowel. Others, it's your own wish. Now I'm restricting you, so now the order will matter. Initially, I could have picked all vowels, which won't be the case here. So here we'll be selective and choosy, and this is how a combination works. So the permutation, the general formula for any permutation will be your NPR, where P is the notation, where out of n objects, I am using permutation on R objects. And for combination, it will be NCR, where out of n objects, I am trying out different combinations using R at a single time. So that would be it. And how is it defined? So this is equal to your n factorial minus n minus r factorial. And your NCR is equal to n factorial upon n minus r factorial into r factorial. So by this, you can clearly see that your NPR is equal to NCR into r factorial. This is quite a useful one and it comes in handy. Anybody, any doubts or any issues till now? Okay. Moving forward, we'll see the cases when and how it is to be used. But just getting acquainted with the formula, uh, how do we calculate quite easy? Like if I give you 15C5, will you directly go for the formula, or you guys know any shortcut? Anyone? Okay,
I
first of all,
think
before that, just a minute, Aswik. Before that, guys, you everybody knows what is n factorial, right?
Yes, Casey.
Anybody who does not know what is n factorial? Okay, okay. So that part is great. All right. Yeah, yeah, Aswik, go ahead now.
uh, I remember, but I don't know if you correct me. 15C5 can be written as 10C5 also.
No,
Or it's
15C5 cannot
10.
be written as 10C5.
It is 10P5.
15C10,
Yes,
15C10.
15C10. Yes, correct.
15C10. Yes,
15C10.
yes, yes. 15C10.
15C10. Perfect. But you have just given me a synonym. I want the answer. How to calculate the answer? Do we have only this, or do we have a shortcut one? Like if you guys know that, that would be great. Otherwise, I'll teach you that. I mean, if I have to use this formula, it will be a pretty hectic task. What I'll have to do is 15 से लेके 14, 13 and all 1, and then I have n minus r. So n minus r would be 10 factorial. So 10 into 9 into so on till 1. And then r is 5. So 5, 4, 3, 2, 1. Pretty hectic task. This 10 numbers, 5 numbers, 15 numbers. Multiplication itself will take at least 1 minute if I'm quick enough. Is there any shortcut method to calculate this one? Or is this the only method available?
We can directly write till 15 to 11 and cut down the 10 factorials. And then,
Okay,
but
and
then again, we have to even spread out 5 factorial down.
yes. Ashwik, you, I would say you are somewhat closer to a shortcut, but not quite there exactly. Okay, guys, I'll tell you, don't worry. So the shortcut, basically what you have to use is whenever given any NCR, so as we have seen, NCR is also is equal to NCN minus R from this formula, where R was 5. Why so? Let's say this is R. Let us use this as this one. So let's put it capital R. This capital R is basically R small r. So how will you deduce the formula from here? N factorial by n minus r factorial into r factorial. Perfect. And what will be nc n minus r? Let's do that as well. So that would be n factorial upon n minus, because this is our new small r, right? So substituting this here, we will have n minus r factorial into, now this is our r, so n minus r factorial, which is nothing but both of them are same, right? Therefore, by that logic, this will be the same. Now what you have to do is, among these two, choose the one that is closer to 1, whether r is closer to 1 or n minus r is closer to 1. You have to choose that one. That means if I will be given choice between this and this, choose this one because 5 is closer to 1, or I say 5 is nearer to 1. So what I will do is, let's say 15C5, I will write 15 by 5 directly, 14 by 4, 13 by 3, 12 by 2 into 11 by 1. That's it. No need to go further. And this works for every factorial, any combination that you will get in NCR, provided R is the smaller one. R or n minus R, this R should be the smaller one. Just use the formula like this anytime, anyways. So let's say I give you 15C7 and 15C8. Which one will you use?
7.
Yes, 15C7. Okay. So let's take a small simple exercise so as to get it completely cleared, and you can use your calculator. Uh, please calculate these values. You can use your calculators. So I'm giving you 1.5 minute. Chat box answers. Hurry up, guys. I've allowed you calculators. This would be quite easy. Manideep, you're correct. Swik, you need to check your first one. Any NCR will never be in decimals. You'll not get a decimal answer. Anshula, correct answer. Yes, Janvi, correct. Correct, Uttam. All right, so I guess we have got the hang of it. So yes, the first answer, as everyone has got it, is this, and this is the second answer. And yes, guys, this numbers will be your perfect integers. They won't be in decimals because of the simple fact that the number of ways of doing a thing is never in decimals. Okay, so let's move forward. The important thing, guys, in PNC would be we will always have templates. Now, what is a template? I would say template is a basic structure. Like I said, you cannot have too many new innovations in PNC and probability. We have a few type of questions. You should know the basic formula. or if you don't know the formula, you should be very well versed with the basics at least, so that you can solve them. And these templates are quite the basics, where I would say they're like the structures in which the questions are generally asked, or questions can be framed. So let's move to the first one. And just before that, let's handle two things. What are situations or events? So any experiment that occurs is an event. How I know this is somewhat a bit of a probability part, but this is quite important, and you will understand PNC and probability, both of them great. So any experiment that you do, and however low or high chances or number of ways there are, you can have them as an event, and those event can be inclusive or exclusive. How inclusive or exclusive? Let me give you an example. Uh, I have a dice and I have a coin. Now I toss the dice and the coin. Here comes 6, here comes heads, here comes 5, here comes tails. Now, after getting 6, I got here a head. Okay, fine. After getting a 5, I got here a tail. But I could have also got here a head, because what I get here is in no way related to what comes here. Hence, they are exclusive events. It doesn't matter. What happens here is in no way influencing my decision what is going to happen here. Let's say if I give you the scenario where only if I get an even number, I will toss the coin, otherwise I won't. Then it has become an inclusive event, because what is happening here is influencing my decision. So we come to a small principle, and that is called the principle of multiplication. In this, and this is for inclusive and exclusive both. So let's say uh, an event, anything in any experiment, this can be done using P ways, using Q ways, using R ways. This three ways, number of ways, using various different criteria, various situations, or anything, various constraints. These are three ways through which this can be done. Now, the total number of ways through which, and provided these all are inclusive, they depend on this, so they are inclusive. That means they are related to each other. So this will be the total number of ways in which this thing can be done. This experiment can be performed in this number of ways. Let's say these were completely independent events. Completely independent. Like, how can I make them independent? Suppose uh, simple, like this is your bus, and the number of people that uh, travel through it, if they are odd or even. Odd or even. Now on one day they can be odd, another day even, another day odd, another day even, and so on. They two have no relation. So let's say this is the number of ways this is done on that day is P, this is Q, this is R. Since they have nothing common and they are not dependent on it, they will be added. That's the thing you will have to remember. A short thing. I know this is just a theory part. When we get to the questions part, it would become much clearer. I will give you that part as well. But the theory part, anybody has any doubt?
Okay, sir, can you just explain the whole principle of multiplication again?
Acha, okay, sure. From here?
Yes.
Okay. Okay. So the principle of multiplication states if any experiment can be done in P ways, Q ways, and R ways, the total number of ways of doing that experiment is basically P into Q into R, where they are inclusive. So all the inclusive ones are multiplied to each other because they depend on each other. Now, let me tell you, give you a simple example. Let's say I give you a small basket which can carry 6 fruits. And there are total 12 fruits, out of which 3 are oranges, 3 are mangoes, 3 watermelons, and we have 7 apples. And all of them are quite unique and all. Or let's consider even that, not even that part. Let's consider all 12 unique different kinds of fruit. One is orange, one is apple, one is guava, one is pineapple, all different. So how many ways can we have different fruits? They will all be different, right? Everyone will have a different one. Now let's say I provide you some constraints that I will have to keep one apple. One apple is to be fixed. Now you do whatever you want. Now what we are doing is we will fix one thing, and according to it, different things. So one will be apple, one apple is done, one orange, one and different things. So what can happen is, see, 12 fruits, one apple is fixed. How many places was there? 6. Now how many places remaining? 5. And from how many fruits you can choose these 5 places? 11. Right? Now let's do a derivation part. How can we get this 11 fruits? How is it possible? Now 5 places, 1, 2, 3, 4, 5. 5 places are remaining. How can we fill this first position? We can fill it in 11 ways because we have no restrictions now. Now one fruit has been picked, one place has been taken. How many places are remaining? 4. How many fruits are remaining? 10. So in how many ways can I fill this position? 10. Next position, in how many number of ways can I pick? Because there's just one fruit of each type. 9 ways. Similarly 8. Similarly 7. So the total number of ways in which I can fill this part will be equal to 11 into 10 into 9 into 8 into 7. Is this part clear, Janvi, now? This is what is your principle of multiplication.
Yes, yes.
Okay, perfect. And
So
yeah, go ahead.
so basically for dependent events we have to multiply, for independent events we have to just add, correct?
Yes. You can have a combination of two. Like there can be 3 inclusive events in this. So this might be P into X into Z, then Q plus R. You can also have like various different things. Those many tough questions are generally not asked, but you can have the possibility of having that too.
Okay.
Yeah.
Kesari, if we
Yes.
take an example of selecting a ball from a bag or something like that. So is it,
Sorry. I could not hear you. Your voice just got blurred. Can you
uh,
please repeat again?
yeah, if we take an example of selecting a ball from a bag,
Yes.
so is it an independent event or is it like we use multiplication?
Depends on what is present inside the bag. Let's say, and what you're doing now. What I do is, in after picking out the ball from the bag, okay, do I place it outside or I again place it inside before picking the another one? Let's say you have just one ball in the bag. I'm picking that ball and placing outside. Next step, can I perform the next step? No,
No.
I cannot. But if I'm not placing that ball outside the bag, I'm placing it inside only. I can perform that experiment n number of times. Now just imagine if there are some 10 or 5 n number of balls which n is greater than 1. and then you ask me where there are 3 white balls, 2 red balls, and different combination, any combination you take, and then you ask me how many number of times is there a chance where a red ball can be picked, the number would be quite big because the balls are being replaced. I'm picking the ball, I saw it is red, I'm placing it down. Suppose I become so lucky enough that every time I get to pick up a red ball, the number of happenings or the number of occurrences would be almost infinite because I will always pick up red ball. Now I give a slight twist. I replace the ball. Sorry, I do not replace the ball. I just keep it outside. I pick up the red ball. If it's red, I will keep it outside. Will the number will be that big like in the first case? No, because at some point your number of red balls will get exhausted. I hope I cleared whatever you had asked, or
Yeah.
you still want some explanation?
No, I got it.
Okay.
So depending, I mean, ultimately, if we put the ball inside the bag, can we consider it to be multiplication then? Like,
Yes, it is multiplication.
okay, so what if I place it outside? Does it become addition
It
or
is still multiplication. You are just restricting the number of cases. Like I had restricted here, one fruit apple has to be already there in the basket. It will still be your inclusive case. It won't become an exclusive case. Exclusive is like I said, you go to the office every day, and whatever work you do, you do not have to carry any work from the previous day. So what is the number of projects that you can complete in a day? So let's say you work for 10-hour shifts and you have projects of 1.5 hours, 2 hours, 3 hours and different lined up. So let's say the total number of ways you can do a project on the first day is 4, second day 3, third day 2, fourth day is 5. This is the number of projects you can do on each day, and they are not related to each other. Will you multiply in that case the number of projects that you can do totally?
no, this time.
That's an addition case.
No.
Is it clear, guys? Everyone?
Yeah.
Okay. So now starting with our template part, and quite the basic ones to start with. This template is when the number of their items present is n, and of which we have different types of similar items among n. So P will be of one type, Q will be of one type, R will be of one type, and so on, where all this summation is equal to n. So now the total number of arrangements that you can get in this, no restrictions, there are no restrictions, will be n factorial by p factorial upon q factorial upon r factorial. For guys, if you had studied this in your 11, 12 standards or something, you might have heard this in your multinomial theorems. Just for knowledge, this is nothing to do with what you have to learn. This is not what we are learning right now. This is just purely knowledge perspective. Just a quick small hint recap.
Casey, can you repeat what P, Q, and R are?
Yeah. So I've given an example too. So let's say there are 10 fruits. So out of 10 fruits, 3 are oranges, 2 are apples, and there are 5 guavas. And I've been asked, choose the number of ways in which I will choose, or in how many arrangements can I arrange all these 10 fruits. Right? So this is the total number of ways in which I can arrange all the fruits. Got this clear now? Anybody any doubt in this case? Pretty basic one to start with. I mean, this is just the extension of your NCR, where there you had normal cases. Here you have some cases which are similar. Okay. Everyone clear? I will move to the next case. Okay, perfect. Let's move to the next one, and that would be the number of arrangements where you have n distinct items, same again, n, and each item can be used any number of times, like the ball one, where you are replacing the ball. So what is happening is, if I picked up the red ball and I'm putting back again, now how many number of ways you can get, or how many number of combinations you can get. So to just state it again, what you will have is n is the number of total objects, and repetition is allowed. That means you can use it any number of times. And guys, please note this down, because these templates or formulas are, I would say, the basis ones, because even if you don't remember your basic concept wise, this formulas can save you. Or if you don't want to learn the formulas and understand the basic, that is fine too. I have no worries with that part. The only thing is we should understand what is going on. That's the main part in PNC. If you don't understand what is going on, it can come backfire completely. So yeah, moving back, you can have it any number of times. So let's say, and using this from the NPR wala formula. So let's say the first box and second box, there are various boxes, different boxes given. Okay. Now if the second box can be filled, first box, second box, third box, this can be filled using n items. Even this can be filled using n items. There are r boxes, and the repetition is allowed. The number of items through which you can, let's say you have here almost infinite, where each box can accommodate n items. Each box can accommodate n items. They are not infinity, but greater than n. And each box can accommodate n items, and there are total r boxes. So the what will be the total number of ways in which we can fill it? Anyone? Any guesses? Try using the multiplication principle.
Is it n factorial
N power
into?
r.
Yes, quite correct. It is n power r. We can fill each item, sorry, each box using n number of ways, right? And they are quite related, because whatever I use here, I can also use it here. So it is dependent completely. And this total experiment, now since it's a single experiment, what I will do is use this one. Where did it go? This part. So using this, n into n into n, how many times? R times. So it will be n into n into n, r times is basically equal to n raised to r. Anybody, any doubt? Okay, let's move forward then.
Kesari, here those boxes are not dependent, right?
Sorry.
Now the
Go ahead.
boxes there, the boxes there where in which the items are getting filled, it is not a dependent task, right? It is not like if it is filled with n, then the other box will only have n minus 1 items to be filled. Yeah, that's the reason. It is since repetition is allowed.
Yes.
There's no dependency.
Yes.
So if there is no dependency, then all the events are independent events.
Ashvik, I'm not able to hear your last sentence. Could you please repeat it?
in that case, we have to add the things, right? N plus n plus n plus n. In case, since these are
Okay.
independent tasks, why we should
Mhm.
add those, right? We shouldn't multiply.
Ashwik,
Right?
your voice is breaking, but I got the gist of what you were asking. Okay. So you are basically telling each different box is independent to each other. So what you will see is instead of multiplying, you will add it.
Correct.
Is that what you're trying to say?
Yes, yes.
Okay, okay, okay. All right. Let me explain it to you in a simple manner. So there are 100 items and your n is equal to 20. Okay, fine. Now all these materials can be reused. That means once I placed it, they will again go back to the lot, and when I have to fill this box, they can be earned one. Okay. And let's take another case. 100 and a box. Again their n is equal to 20. These are two separate cases. And here, once you fill it, you cannot take it back. So repetition is not allowed. Now tell me, okay, repetition is not allowed. Now there are next box. In this next box, how many ways out of how many things you can pick up now?
80.
80. For the last one, when you have the fifth box, how many choices you will have?
20.
So will there be constraints?
Yes.
So here the cases will be more or here the cases will be more?
The above cases will be more.
Second one will be less, right?
Yes.
Okay. And in second one, every time you will have 20 choices because repetition is allowed?
Every time we'll have 100 choices. Yes.
Yes,
Yes.
because repetition is allowed. You will have more choices.
Correct.
So in which case will your answer be bigger?
First case.
So 20 plus 20 is bigger or 20 raised to 5 is bigger?
20 raised to 5.
I know sometimes it becomes PNC ka that's an issue. Like this is nothing to do with the quant part. This becomes like a separate field of maths. So sometimes it gets a little fuzzy, but what happens is when we start solving the problems and analyzing it, it becomes much easier. Interpreting examples in PNC is the toughest part. So that's the reason just going basically through all the templates, and once we start using the example part, that would become much easier. Don't worry. So even if you are understanding 70 to 80% here, rest assured, you are understanding more than what is required and you can clearly solve the problems. Ashvik, there will be some problems which will be quite similar to it. Even if you still have doubt, you will get it cleared there. And don't worry, even if you have doubt after the example, I will clarify that doubt.
Sure, sure.
Okay. So now coming to the total number of combinations. This is Ashvik, this is quite similar, not exactly same, quite similar to this case. Now total number of combinations. Now let us take yet again, this will be a quite fixed. N is the total number of things that are given to us. And the number of ways of selecting one or more things that can be from 1 till let's say this n. Here your n was greater this and you could only take 20 here, right? What if once I start taking it and repetition and all is not allowed, but I do not have any restriction on how many items I can choose at one time, right? There is no restriction. So how will I choose the total number of cases? This is quite similar to this one. Quite, I mean slightly. Okay, let's see. Let's say box is here. Okay, back again. First time out of n, I chose, let's say, just one, right? And each combination has to be unique. Or no, don't take this one. This would confuse. Let's take one box only. Let's take one box only. And you have total n number of balls. The capacity of this box is unlimited. You can fill infinite number of balls. But what is the total number of ways in which you can fill this bag? How will you calculate it? Anybody? Anyone? I'll give you 30 seconds to think first. Let me know. Prerit, I didn't understand your answer. Can you please explain? Guys, anyone? There is no restriction on how many balls you can fill. Start by taking a simple number 3. Let's say there are 3 number of balls. In how many ways can you fill this box? Start counting, you'll recognize the pattern. If you guys cannot deal with n and all, take small examples. It becomes much easier. How come 3 ways, Manideep?
We have only one box, no, Kesri,
Yes, one box.
and 3 balls, which can
Yes.
be done in 3 power 1, maybe.
3 power 1. I sure I can already count 4 ways. Okay, Prerit is telling 6. How come 6, Prerit?
Can be done in 3 factorial ways, right?
Yes, Prerit. Take any case, whatever you wish. Restrictions are totally up to you. Whatever restrictions you want to take, or if there are different cases, go with that as well. I've given you the open option. So if there are 3 distinct balls, you say 6 cases. How come? Please explain.
Yeah, if it is distinct balls, then uh, the order the order of putting it like 1 2 3 and then 2 1 3 3 1 2 like that. So
Okay.
since they're different balls, so we have uh, 3 factorial ways of putting it.
Okay. Acha, so that's how you come to 6 then.
Yes.
Okay. And what if they are not distinct? Then what will be the number of ways?
Even if they're not distinct also the same number of ways, right? Because
Still
here
the same.
yes, I believe it should be the same because here we have the item. It doesn't matter if it distinct or not distinct.
Okay. Uh, Fine. I have 3 red balls. Exactly similar. Now they are not distinct, right?
I think if they're not distinct, it is only one way, I'm assuming. I mean, when all the balls are red,
Ah, yes, all the balls are red. And you
so
cannot differentiate between them.
so
And
it'll
I have
only
just
be,
one box.
yeah, it'll be only one way possible, I think.
And that would be?
I mean,
And
it
what
could.
would be that one way?
I mean, it's irrespective of the order, or I mean, there is no order as such, right? It's only
Yes,
like
yes.
all the
Order is
balls
not
inside.
important.
Yeah,
Yes.
so all the balls will be inside the bag.
And what if I put no ball inside? Will that not be a case?
Okay, yeah, that will be on the next case. Yeah, so total
Uh,
4.
Yeah, I think I have missed that one.
yes, yes, you missed that one. And what if I put just one ball inside? Will that not be a case also?
And then in that case, only 2 balls, and then again all 3 balls.
Yes.
in there.
So what will be the total number of cases, guys? Prerit has now corrected his answer, and yes, that is correct, Prerit. Yes, Pandana, what will be the number of cases then?
No, I mean, no ball at all, and then 1 ball, 2 balls, 3 balls, 4 ways.
Yes, now you are correct. It's quite the same. It's 4
Oh,
balls. And when it is a totally distinct one, then
uh,
if we include 0 cases as also a case,
so instead of 3 factorial, will it be mm, or do we subtract something
then
from
it
the
will
3?
be 3 factorial plus 1,
Okay, plus
and
1.
this
Okay.
plus 1 for empty.
Okay,
Generally, what how you will be played is, see, uh, how you will be played. Let's say this question comes in cat. Now I'll tell you the trick how your options are being set. Simple question that might come in cat, and they will play with your options. So the question is similar. One box, 3 balls, all 3 are red. The number of ways in which this box can be filled, and they have given no further information. They have never said the box can be empty or not. And you can take your chances there. Then you can assume, because if they had specified the box cannot be empty, you will have to discard this case. But they have not said so. So how will they place their options? It will be this, it will be this, it will be this, and the fourth one might be none of this or some random option. The highest number of cases would be this. Somebody who is who knows how to play with options but doesn't know the right answer, he might be confused in this and this, and then you know what is the correct answer. This is how the options are being built, even in geometry, even in various different things, to catch you guys. Like once you get into the analytics part of how people answer what all options and everything, you will come across these patterns quite in a good number of questions. And this is the same even in your VARC as well. Generally, like let's say I ask you an VARC passage and the correct answer. So if this is the correct answer, this will be also the fact from the passage. This will not be a fact from passage, even though it sounds similar. And this will be somehow differently done. And then if you struggle upon a case where you come across two options and then you cannot choose among the right ones and you generally choose the wrong ones, that's because this factor is somewhere hidden in the passage. This is more visible in the passage. So generally, like this was the case with me. Among the four ones, I would eliminate two options. Two options were left, and I always chose the wrong one. I would go to the teacher and ask them, how do I rectify this? You know what was the reply I was given? What you do the same thing. Eliminate the two options. When two is left, generally which is what you choose, do not choose that option, choose the other one. This was the reply given to me in verbal. Even though it was a joking one, it did work on some questions, but I got confused again. So basically, this is what I wanted to tell you is how the options are being designed. So knowing what are the weaknesses, I mean, what are the do's and don'ts of a question is sometimes what helps and what is become quite important in CAT over the recent years. Earlier, I mean, not early exactly now, but I would say 6, 7 to 8 years ago, or even 10 years before, that wasn't the case. You had just one right answer. These were not that close. Now, see, now they are quite close. This is the structure, how the options are being set and all everything. So, anyways, that was enough gyan for cat 1. Everyone understood how you'll get 3 factorial plus 1 cases? Anybody any doubt with that? Okay. Moving back to our original point of total number of cases. So now what we have to do is we have to choose all total number of possibilities. All. Here the possibilities were restricted, but now what is given to you is out of n given things, the total number of ways of selecting one or more. One or more number of things, like starting, that can be anything, 1 2 3 4, anything, one or more, because it will start from 1, it cannot be 0. So this case, this one wala case is eliminated. One or more number of things till n at a time. That means in a single go, the total number that you will have is, let's say initially from n you chose any one, and here they are distinct. Next time what you did is you chose 2. Next time you chose 3. Similarly, you can choose any number from 1 to n, because that is what we were given. Now anybody can tell me what is the sum of this? Anyone? What is the summation of this? Because this is all the number of cases and it does not depend on first case, does not depend on second, so they are exclusive events. So the principle of multiplication is not applied here. Anybody, any idea? Yeah,
Is this
go ahead.
something to do with the binomial theorem or something? One
Yes,
plus
yes, it is binomial theorem basically.
1 plus something, it will, I don't know the
So
formula.
what is the answer here?
Basically,
Yes.
1 plus something, I mean, like it's a formula. 1 plus
That
something whole power
that
n.
was, yes, that was your binomial theorem, 1 plus x raised to n. There is no x here. Think. There is no x here. There you had this. And you used to have x here, 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 here. There is no x here. So you cannot give an x in the answer. But you can still derive using that. What you said is quite correct. And using that, this formula is being derived. But Does anybody have any idea, guys? You have studied this. Trust me, you have studied this. It's just a matter of remembering. I'm not asking you to go search Google. If you guys remember, it's fine. If not, we'll move forward. I'm giving you 10 seconds. Think if you guys remember it or not. Little stress on the memory helps. Why should it be just the exam where we stress our memory? Think. Okay, all right. Well, guys, the answer here is 2 raised to n minus 1. Why minus 1? Because we are not taking this case. That's why we have subtracted that case, the empty wala case, because we start with 1. And Spandana, what you were telling, yes, 1 plus x raised to n is equal to nc0 plus nc1. So here you will have x raised to n minus 1, and ncn has x raised to 0. If I put x is equal to 1, I'll get this one, this all x wala term will become 1, and 1 raised to anything is 1. So all x wala terms will vanish. No x wala term will be remaining. And what you will have is nc0, nc1, and all is equal to 1 plus 1, 2 raised to n. So if you take this side, this is basically 1. You will derive this formula. So what you were telling was quite correct. You just had to take one step forward. That's it. Everybody clear with how we got this formula? Any doubts? Anyone? Okay, perfect. So what you can do is just take a note of it, that number of ways of selecting one or more items from n given items is 2 raised to n minus 1. Okay, let's move forward now. So now we'll see how we divide the items between groups. Sorry, this is not a question. This is again the template. And that is, how do we divide items between groups? Let's say there are 2 groups of items, and each has, first group has p items, second group has q items. And this is quite the similar extension basically of this one. Where did it go? Yeah, this one. But here you this is just that the one I'm explaining it's just another way of this question. So here your p plus q will be n. So what you will get is quite similar. So when you divide it, I mean, this is just the reverse. When you divide n into p and q, two different groups, the total number of ways in which this can be done is p plus q factorial by p factorial and q factorial. The special case would be when p and q becomes equal. So let's take p is equal to q is equal to x, any number. So what will happen is 2x factorial upon x factorial, or this is 2x factorial upon x factorial ka square. How do we arrive at this formula? 2 ways. First, the above formula we can directly apply, n is equal to p plus q. Second, let's even if you don't wish to interpret it that way, let's go with the basics, and that is total items we had initially. There we had n, here we have p plus q. If we select the first p items initially, how can we select p items? That would be your NCR. That is how we have choose the number of items. So how we'll have here, what is the n here? N is p plus q. So we'll have p plus q c p, because we are choosing p items. Now, how many items are we left with? We are left with q items, correct? Now, how many groups have we formed? We have already chosen p, and we are left with Q. So how many groups do we have? Two groups, P and Q. So P plus Q items can be divided into two groups in how many number of ways? That means in how many number of ways I will choose P and reject Q, or even the other way around. I will choose Q or reject P. It will quite be the same because NCR is also is equal to NCN minus R. I might sound little confusing. Let me repeat once again. The complete case. N items are given to you. Out of that, you have chosen P and rejected Q. Rejected Q. P selected, rejected Q. So basically what you are doing here is you are separating them into two different groups. What is the total number of ways of doing it? This is the formula. And this will be the same if we select P, reject Q, or the other way around. We select Q and reject P. Why? This. Is this part clear? Anyone? Anybody, any doubt? Okay. There are one special case, like I said, the case where this one P is equal to Q, while a case which we had discussed here, this one. What unique factors you might face in that case, and that would be two cases basically, and when P is equal to Q, and that would be the two groups will have either distinct identity or they will have the same identity. This you will come to know how your question has been set up by the question setter or what type of question you get. But this is just the two cases that you will have. Either they will have the same identity or they will have different identity. How we'll see in a question when the question arrives, or you will have that type of question in an assignment. PNC ka assignment, guys, you will have different because that is quite different from algebra, but the rest of the algebra part will be quite similar in the structure and approach part. Or if possible, I will try to break the complete algebra part in small two chunks maybe, because while I was designing the worksheet, I figured out one, the worksheet is becoming too huge, and the second, it will be more challenging if I design a complete worksheet on algebra than two worksheets on algebra. So the two worksheets will be like the groupings are being done, like special equations, linear equations, and quadratic will be in one go. Your graphs, then functions, and questions related quite similar to functions will be in one go, and other algebra parts will be here. PNC wala part will have different because this is in no way related to this or this. So this was just the basic thing. How and what it matters will be when we arrive at the question. So is this part clear, guys? Everyone? Till now? Anybody, any doubt moving forward? Okay. So just to give you the formula, we'll see how it is done when we see the concept. So like I said, when they have distinct identity and when they do not have distinct identity, the formula would be, let's say P is equal to Q. So that would be, and when they are not distinct, This is your formula. Now I want explanation from someone about the significance of this highlighted part. How did we get this? Who will explain? How did this come? I do not want how the formula has been derived. That we have already derived. How did this 2 factorial come in the bottom? Anyone? Guys, is PNC that difficult or that challenging? Or am I teaching very badly today? Or is there some network issue and I'm just speaking to myself?
No, no, actually, there's a lot to take in a single day. That's why.
It is,
That's the only
that's
thing.
the thing, that's the thing. Yeah, I can understand that part.
Maybe when
PNC,
we are doing sums, we'll get the essence of all the formula.
I can understand you guys. See, I won't lie, but even when I used to study PNC, my eyes would get closed after 15 or 20 minutes or so in the lecture. So I can understand that part of yours. The only one formula which I generally dependent on is this formula. Where did it go? Yeah, that's it. This is what I just kept in the mind for solving. If you guys can apply this anywhere or everywhere, you are done. You don't need to remember anything. But if you master it 100%, which is very difficult, because sometimes using a direct formula can save you 2-3 minutes. But if we start using this everywhere, this might take 3-4 minutes. But using a formula, it can take 1 minute. But if you know this one, you don't need to remember any formula. But for that, you will have to master it. And mastering it is a bit difficult. So I used to apply this in mostly 60 to 70% problems. I was quite above average in this formula part. Application of this formula part, I was above average. But there were 2-3 types where handling that formula would become difficult. So I would understand the basics and memorize the formula. So that helped. So if I would say the strategy is totally open up to you guys, how you guys wish to tackle PNC, because yes, this is one of the biggest nightmares for quite everyone. However good at quant you are, however bad at quant you are, PNC never leaves everyone. PNC is like the deathly hallows of Harry Potter part. You
Yeah,
cannot
how
escape.
many questions can we expect, Kesari?
I was waiting for this question right from the beginning. Hopefully it has come after 1 hour. See guys, how much do you think should be asked ideally?
Max 2.
Okay, so if I give 2 questions in the paper, you will be fine with it. And what if I start giving 4 questions from this chapter? PNC and probability combined.
That is the biggest nightmare ever.
Okay. See, I won't say you are at a nightmare, or I won't say you will have a cakewalk, but you from PNC and probability, 2 to 3 questions you can easily expect. If 4 has been asked, yes, it is a nightmarish paper. Can't help it. You will have some mock tests where 4 might be asked, but that is only to purposely put you into a situation where what if a tough question appears in CAT? Tough paper, I mean to say. If you have a easy day, very easy day, if you are like, if you have woken up on the right side of the bed, eaten the right breakfast, seen the right faces in the morning, you will have 1 question. But this is ideally the scenario, 2 to 3. 4 is rarely asked, but on a general note, 2 to 3 you can expect, and 1 will be quite easy. 1 you can easily solve. Even in, I just ask you in the middle of the night, you are half asleep, you can easily solve 1 question. So that's not an issue. But for that 1 or 2 question, I won't be that full to live PNC and probability, because what happens is
Even if you have 4 questions asked, there might be a scenario where excuse me, 2 easy questions and 2 medium questions. There's no tough question, because the CAT paper setters are sometimes quite cunning in the way that what they will do is they will give you questions from chapters which you are not comfortable with, and they will also give you questions from which you are comfortable with, the general, because they have the general consensus, general idea as to how the things are done. And the chapters which you know, those might be medium to tough, and the chapters which you do not know or are not much comfortable with will be generally easy to medium. And if such a paper arrives, trust me, this is the worst nightmare. That's why you should have the basic idea of every chapter. And hence I would advise, even if you guys are very terrible at PNC and probability, still have the basic idea. You should at least get this part mastered, applying this principle of multiplication to at least 40 to 50%. This is a must, I would say, because if that's the case, you will have at least 2 questions you can easily solve out of 4, easily, using option elimination and everything. Okay, so Prerit has asked, everything is going above the head, and is 2 factorial because NCR is equal to NCN minus R. Yes, you can say it that way, or yes, that is quite correct, Prerit. NCR is equal to N minus R is why there is 2, and also now here they were distinct, right? Here they are not distinct. So there are 2 twins. Let's say P and Q are twin brothers. But in this case, P has a black dot. P has a black dot on his head, through which you can identify. This case, P and Q are exactly similar. There is no black dot. So you won't be able to identify which one is P, which one is Q, and they'll look exactly similar. So if you get 10 number of cases here, you will think basically there are 5 number of cases. Why? Because you won't be able to differentiate between P and Q. You will get repetitions. So you will have 2 here, and basically these are 2 number of cases, hence 2 factorial. So in a way, what you are telling, NCR is equal to N minus R, closely correct partially, but not completely. This is the main case. Basically, you will get duplicate cases. Prerit, what went above your head?
Like, it's not totally above the head, but when it comes to theory, it's kind of boring.
Yes, I can understand. Unfortunately, like PNC is a chapter. I mean, it could have been idle if we could have got 3 hours on a stretch, like 3 hours in a stretch. I mean, 1.5 hours, then have some 10-15 minutes break, and 3 hours. Then I mean 1.5 hours. Then PNC is such a chapter, it requires such a scenario. Unfortunately, we are locked in the part wherein if it's not a weekend, somehow because of our schedules, there are various clashes and we cannot have such a session. What we'll do is today we'll just see the basics at least, and we'll come to the problems next time as well. So you don't have to worry, we won't be going anywhere, and it's not that I'm robbing you of the thing that I will only just explain the theory, I won't take the problems. The problems will be there, don't worry about that part. But for now we'll have to content ourselves with the theory part. So at least okay, it might sound gibberish and everything, but does the formula make sense to you, how it has derived everything?
Yes, Kesari, that is
Okay.
totally fine.
Okay, so we are almost done. Now just moving to the circular part. Guys, the thing is, there's a lot of theory. Like if I have to say theory wise, how much theory I have covered for PNC, I would say till now 50 to 60% theory. Theory wise, this is quite vast. I mean, the theory for PNC and probability is almost similar to numbers, but the only part is I spent so much time in numbers is you can have 7, or if the question paper ka favorite part, then you can have 8 out of 34. That's like almost 20 to 25%. And that's the reason I spent almost 4 lectures on numbers. We'll spend some time, so don't need to worry. We'll just see the basic of your combinations in a circular arrangements. So this is quite similar and same. Now just remember this part, guys. This concept, how we got 2, we will be using it in circular ones. It's quite similar, not exactly the same, but quite similar. So what we had initially was, if we are given n objects and we have to place it in a line, what is the total number of cases that I can get? Total number of observations? Anyone?
Yes, I didn't get your question.
Okay, there are n distinct students and I have to arrange them in a line. School ka subah morning assembly line. How many number of ways can I arrange the peeps?
And factorial?
Yes, perfect, and factorial. Now I have n students, same, but now what are they doing is they are sitting in a circular. Now in how many number of ways can I arrange them?
n minus
n minus 1
Minus 1
factorial.
factorial.
Okay, so everybody knows, great. And why this partiality? Here n minus 1. Why so?
Because the starting and the end point collide at one point.
Collided. Okay, I'm hearing
No,
different.
not collided. Like they get in touch.
So what you said is quite correct, but then what happens because of that? You will have repetitions of n cases. See, you will have repetitions of n cases because there are n number of students, and every student will get a chance of be the first student, and this first student will also be the ending point, and this will happen with n number of students. So the total number of cases will be n factorial, but this will be divided by n because every student will have the first position for one case, and that is why because of this we get n minus 1 factorial. Is it now clear, guys? Now coming to one more twist in the tail. Clockwise and anti-clockwise. Okay, before asking this, just a quick normal question. And you guys are not to look above. In what direction does the fan move?
Clockwise.
Clockwise.
Are you sure?
Definitely.
anti-clockwise.
Mine moving in anti-clockwise.
Manideep, you were not supposed to see. Okay, guys, this is basically an interview question which they ask in CAT interviews just as a trick question or even in the UPSC exams. when the UPSC results have been today. So the thing is, guys, this is not related to it, but a quick fact. Whenever such questions are being asked to you, the fact is not being asked to you, guys. Their main purpose is not to ask you the fact that you have the knowledge or not. The main purpose is how you approach the question and how you answer the question. So a witty answer can be for such a scenario is, so it depends on how you, from what point of perspective are you looking at the fan. From one perspective at the bottom, if the fan is rotating clockwise, if I see from top of the fan, it will move anti-clockwise, the direction will change. So I cannot be sure whether it is moving clockwise or anti-clockwise. Trust me, after if you give such a witty answer, quite one, they won't be going, okay, fine. So what if you are below the fan or above the fan or so? What they wanted to know, they have checked it. So that would be it. Just a quick fact to lighten up the mood that I wanted to anti-clockwise and clockwise. That has nothing to do with this example. So don't hit me with what is he teaching now. He has gone crazy. Maybe. Okay, so clockwise and anti-clockwise, coming back to the original one, there can be two cases. Arrangement where clockwise arrangement and the anti-clockwise direction arrangement will be exactly the same. There might be some cases where the clockwise and anti-clockwise will be different, like red, orange, yellow, orange. If this is basically, let's say 4 people are sitting, now your clockwise and your anti-clockwise is exactly the same. So am I getting repetition of number of cases? Yes, I am. Like here. Where did it go? Yes, here. Hence, I will be using a division by 2. So, if your clockwise and anti-clockwise has no difference, your formula will see a modification of this. Is it clear now, everyone? Okay. Now coming to two very simple things. That is, and this you might have seen in your 10th standard as well. Anybody remembers it?
How many times the word is being repeated?
No.
No,
This
like
is
alphabetically
dictionary.
we have to find
Yes.
the dictionary.
I mean, let's say you have to form a dictionary from pineapple. Okay. I take this word pineapple. I find the total number of words that can be formed using the letters, only these letters. You cannot use extra letters. You have to use only these letters. Let's say 10, let's say, for example, this is not the thing. So let's say I'm given a word, I have to use all its letters, and total number of words I can use form using this letters, and those words may not be meaningful. So you can have any combination. So even X, A, B is a word. Okay, that is, we are considering it. So let's say 10 words are coming out, and in those 10 words, if I arrange them using the dictionary order, then let's say that word comes out to be 6th, that meaningful word which I had to deconstruct. Then the rank of that word is known as 6. Is it clear now, guys? Okay. So the final exercise, hopefully we don't make it too monotonous. Final exercise for today would be, and we have got almost 70% theory, guys, 30% theory still left. We'll stop it here because I can see it has become way too monotonous. We'll continue it some other time after the DILR sessions. We'll come back in between. for just to have uh, I will peg the permutation combination probability sessions in between DILR parts so that you won't have too much of algebra right in between. But the final question for day would be calculate the rank of this word. Or if you guys have not understood what the rank of the word means, please ask me again, I will explain it. Anybody who has not understood?
Case two, could you please repeat?
Yeah, sure. Okay. Let's say there is an n letter word. Okay, like any something. Let's say giraffe. Okay. Now 1, 2, 3, 4, 5, 6, 7. What would be the total number of words that can be made out of this? 7 factorial divided by 2. Is this clear, Spandana?
Yeah, Casey.
Okay. Now, which will be the first word that if I make a dictionary out of this only, what will be the first word? In a dictionary, how does dictionary word? What would be the first letter?
It will
In
start
the
from A.
yes, it will start from A. Then after A,
E.
B.
E. And then these 3 letters I will arrange as per it. Right? So this will be the first word. And gradually I will come down to forming so many words. Right? So this will be the first word, second, third and all. What will be the rank, and by rank, when will this word come? Now did you understand, Spandana?
Yeah, Casey. Yeah.
Yeah. So you will have to calculate first before G. How can so what you will have to calculate is before G with how many letters initial words can be formed, and then you will have to come with G. After G, will giraffe be the first word in this dictionary starting with G?
No.
No. Which will be the first word starting with G?
GA.
Okay, yes, GA, perfect. You will get some, and you will get some number of words that will start with GA, right?
Correct.
After that, you will have GE, some number of words starting with GE. Then you will have GF, some number. Then you will arrive at GI, right? After GI, you will have some number of words that will start with A again. Then some that will start with E. Then gradually you will come to how GIR and so on. And this is how your word will be formed. I want how many words will be formed before you arrive this word. I want the rank of this. Now everybody, have you understood? Everyone? Anybody who has any doubt with this question right now? If it is clear, guys, please type in the chat box if it is clear. That would help me understand. Okay, perfect, great. And guys, I know this is a bigger question and it's quite time. So what I'll be doing is you guys take this question for today as homework, and I want you guys to DM me the answer. I want the photographic solution. Send me a photo of the solution that you solve it of this pineapple. What is the rank of pineapple? Does it work, guys? Because I think it might take 10-12 minutes or so if you ideally set it. Will that work?
Yes, sir.
Yes, yes.
Okay, then this would be the homework, and this would be your homework, and you will have to DM me the answers and the photograph. I do not want the final answer. I want the approach also. So that would be all for today, guys. We have just 3-4 more concepts remaining, but that would be too much for one day. So let's take a pause and break now for now with the algebra part. From the weekend, we'll start with DILR. So that would be something to cheer on. And in between, after 2-3 sessions of DILR, I will peg the PNC and permutation combinations and probability. Sorry, PNC and permutation combination is same. PNC and probability, so that you guys do not get bored. And gradually, I think if everything goes well and we do not take time, maybe by this month end or next month first week, we should be able to complete our portion, and then we'll start with the revision sessions where we will have doubt sessions and asking tough questions, and all the doubts that you would have, we will have sessions on those where we can all clear everything. So that would be the plan for now. Okay, then guys, thank you, and I'll stop the record.